So welcome to all the students for learning management system. In this session we see the subject fundamentals of electrical and electronics engineering. In this subject we see the unit 2 session 5. So in this one we find the equation to find the effective resistance connected in series, equation to find effective resistance connected in parallel, resistances connected series and parallel combinations. Later we will solve some simple problems. Now first we see series circuit. If you see the diagram, in the circuit the resistance are connected in series fashion. The R1, R2, R3 are the three resistances. They are connected end to end, so as to form the chain. So here what happened, the total V is total voltage applied, I is current flowing through the circuit. The V1 is voltage drop across the resistance R1, V2 is voltage drop across the resistance R2, V3 is voltage drop across resistance R3. So the current is remains same, that is I is flow through the resistance R1, R2 and R3. So here the voltage drop across V1 we can write V1 equal to I, that is total current, into R1. So similarly V2 we can write I into R2. Similarly V3 equal to I into R3. So we know that V equal to the total voltage applied equal to the total voltage drop in the circuit, that is V1 plus V2 plus V3. So using the Ohm's law we can write I into R, that is I is total current, R is equivalent resistance of this three series circuit these three series connected resistances. So that is I into R equal to I into R1, the voltage drop across V1, so plus I into R2, voltage drop across V2, plus I into R3, voltage drop across V3. So using Ohm's law we can write like this. So if you remove the I common in between the left hand and right hand side of the next equation, so we get the final equation has R equal to R1 plus R2 plus R3. So if there are n resistance are connected in the series, then effective resistance R effective equal to R1 plus R2 plus R3 plus Rn. So now we come to the parallel circuit. So in this circuit, so R1, R2 or the R3 are the three resistances. They are connected in parallel fashion. So here the two common points we take, and starting end and finishing end of the resistors are connected in a same common point. If you take the starting point of all the three resistors, they are connected in same point, and the end points of all the resistors are connected in the same point. So in this, if you connect the resistance in this fashion, then we say the resistors are connected in parallel. So here in parallel circuit, the voltage across all the resistance are same, that is V, that is also applied voltage, but the current I is the total current flowing in the circuit, that is I. It when enters the resistance R1, R2, R3 is divided as I1, I2, I3. So here the total current I we can write I1 plus I2 plus I3. Using the Ohm's law we can write the total current I equal to total voltage divided by total effective resistance of the circuit. So that is equal to V by R1 plus V by R2 plus V by R3. So if you remove the V from both sides, so we get the 1 by R effective resistance equal to 1 by R1 plus 1 by R2 plus 1 by R3. If there are n resistance are connected in parallel, then effective resistance is given by 1 by R, that is equal to 1 by R1 plus 1 by R2 plus 1 by R3 up to 1 by Rn. So if you see the next, we see the combinations of the series and parallel circuit. So if you see the diagram, the point between point A and B, between that resistors R1 and R2, they are connected in parallel. Then point B and C, between them the R3, R4, R5 are connected in parallel. So these two combinations are connected in series. For this how to find the effective resistance? First we have to find the effective resistance of the resistance between point A and B, that is R1 and R2, which are connected in parallel. So according to the parallel equation, equivalent resistance of parallelly connected resistances, we can write 1 by Rab equal to 1 by R1 plus 1 by R2. So that is R1 plus R2 divided by R1 into R2. Then Rab equal to R1 into R2 divided by R1 plus R2. Afterwards, finding this, we have to find the equivalent resistance of R3, R4, R5. So that also are connected in parallel. So the equivalent resistance of RBC equal to R3 1 by R3 plus 1 by R4 plus 1 by R5. We can simplify R3 into R4 plus R4 into R5 plus R5 into R3 divided by R3 into R4 into R5. So now RBC we can write R3 into R4 into R5 divided by R3 into R4 plus R4 into R5 plus R5 into R3. Now these two equivalent resistance are connected in series. So that is RAB and RBC are connected in series. So using the series equivalent resistance of series formula, R equivalent equal to R1 plus R2. So we can write R total R equal to RAB plus RBC. So now the total resistance of this circuit is RAB plus RBC. Now we solve some problems. So find the equivalent resistance of three resistors, 10 ohm, 15 ohm, 5 ohm connected in series. Also determine the total current in the circuit. So 10 ohm, 15 ohm, 5 ohms are connected across 100 volts. So first we have to find the equivalent resistance. So R equivalent resistance of series connected resistance are R equivalent equal to R1 plus R2 plus R3. So that is 10 plus 15 plus 5, that is 30 ohms. Now using the Ohm's law we can find the current. The total current equation we can give VI equal to V by Req. So 100 divided by 30, that is 3.33 amps is a final answer. So three resistors are 10 ohms, 15 ohms, 30 ohms are connected across the 50 volt supply. Determine the effective resistance and total current in the circuit. So 10 ohms, 15 ohms, 30 ohms are connected in parallel. So we know the equation R 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3, that is 1 by 10 plus 1 by 15 plus 1 by 30. We get 3 plus 2 plus 1 divided by 30, that is a final we get 6 by 30, that is R equivalent equal to 5 ohms. 5 ohms we get. The total current in the circuit I equal to V by Req. So I equal to 50, that is voltage divided by the resistance, that is 5 ohms, that is we get 10 amps. So now we see the combinations of the resistance connected. 5 ohms connected in series with the 2 resistors, 2 ohms and 10 ohms which are connected in parallel. So for this finding the current in the 2 ohms resistance, first we have to find the equivalent resistance of all the connected resistances. So for that one, first we have to find the equivalent resistance of 2 ohms and 10 ohm resistance. So here 2 ohms and 10 ohms are connected in parallel. So equivalent resistance is 2 into 10 divided by 2 plus 10, that is we get 1.667 ohms. So that is connected in series with 5 ohms. The total resistance is 6.667. So the total current in the circuit given by V by R total, so that is 200 volts divided by 6.667, so that is 30 amps. Now this 30 amps is current flowing in the circuit. So that 30 amps is divided when it enters this parallel branch. So that divide into I1 into I2. So now we have to find the current flowing in the 2 ohms. For that we have the equation I1 equal to the total current into the resistance of other branch divided by total resistance, that is 30 into 10 divided by 2 plus 10, that is we get to 25 amps. So 25 amps is current flowing in the 2 ohm resistors. Now students, we solve some MCQs. So first MCQ is, it is preferred to connect bulbs in series or in parallel. So four options are there. A is series, B in parallel, C is both in series and parallel, neither series nor parallel. So here we have to first see that when you connect in series, what happen? Bulbs, if you connect in series, what happen? As I told beginning, that when you connect the resistance or series, the voltage drop across the resistance is different. So if you connect two bulbs in series, then what happen? First bulb will get a different voltage, second bulb will get a different voltage. So here what happen? First bulb will glow more brightness and second bulb will glow with less brightness because of the different voltage drop. So to avoid that, we have to connect bulbs in a parallel. So that in parallel what happen? The voltage across the both bulb will remain same. So the option B is correct answer. Now we see the batteries are connected in dash series, parallel, either series or parallel, neither series or parallel. So if you connect batteries in series, what happen? So you get more voltage. The voltage will add. If you connect in parallel, the voltage will remain same. What is the voltage of each battery, that will remain same. So the correct answer for this one is what? We have to connect the batteries in a series. So A is correct answer. Now question number 3. In a dash circuit, the total resistance is greater than the largest resistance in the circuit. So first option is series, B is parallel, C is series or parallel, neither series or nor parallel. So when you connect the resistances in series, what happens? That the total resistance of the total effective resistance is, it is greater than the largest resistance in the circuit. So the correct answer for this A, that is series. So the A is correct option. Now option number 4. In a dash circuit, the total resistance is smaller than the smallest resistance in the circuit. So option A is series, B is parallel, C is either series or parallel, D is neither series nor parallel. So if you connect the resistance in parallel, what happen? Automatically the total resistance will it is become less. The equivalent resistance become less. So it is the smallest. It is the smaller than a smaller resistance in the circuit. So option B is right answer. So question number 5. What formula would we use to calculate the equivalent resistance if R1 and R2 are connected in series? Now the two resistance R1 and R2 are connected in series. You know what is the equivalent resistance of the series connected resistances. So that is R equal to R1 plus R2. So option C is right answer. So what is the equivalent resistance of two 10 ohm resistors connected in parallel? So two 10 ohm resistors are connected in parallel. So you know the resistance, equivalent resistance, the formula for equivalent resistance connected in parallel. So 1 by R equivalent equal to 1 by R1 plus 1 by R2. So 1 by 10 plus 1 by 10. So we get what? 100 divided by 20, that is 5 ohms. 5 ohms is right answer. So in a series parallel circuit, R1, R2, R3 in series and connected in parallel with R3, if R1 is open, then R2's voltage will be dash. So options are, it decrease, it remains same, C is decrease, cannot tell. So for this, the right answer for this is option C, is decreases. So many resistors connected in a series will be, A, 4 options are there. Divide the voltage proportionally among all the resistors. B, divide the current proportionally. C, increase the source voltage in proportional to the values of the resistor. Reduce the power to 0. So for this, the first option, A, divide the voltage proportionally among the resistor, is the right answer. So what is the voltage measured across the series short? So options are infinite, B is 0, the C the value of the source voltage, D is null. So when the short is series short is occurs, the voltage is always 0. The B is right answer. So find the current in the circuit. So total current is, we have to find the current in this circuit. So 20 ohms and 40 ohms are connected in series. 120 volt is applied across this one. So we have to find the current. So to find the current, we have to apply the Ohm's law. I equal to V by R. So R is for this is effective resistance. So here the resistance 20 ohms and 40 ohms are connected in series. The effective resistance equal to R equivalent equal to R1 plus R2. So that is 20 ohms plus 40 ohms, 60 ohms. The current given by V is 120 divided by R. So that is 60 ohms. So 120 divided by 60, 2 amps. B is right answer. So here we come to end of the multiple choice question. Thank you for watching the video. Thank you. I thank LMS content team members for their constant support and suggestions. I thank Srimati D. Aruna, the chairperson SJ Polytechnic Bangalore, Shri Vijay Kumar, coordinator GPT Chintamani, Srimati Shilpa, member SJ Polytechnic Bangalore, Shri Wazid Ahmad, moderator GPT Immadhalli Bangalore, Shri Hemant Kumar, e-content developer GPT KGF Kolar. So thank you one and all. Thank you.